Good afternoon, everyone. Thank you for joining today's Resideo webinar session. We are excited to be providing an overview of the new Resideo Hydronics products that we have launched in March of 2021. My name is Jamie Quanrud, and I'm part of the Resideo Sales Training Team. And on behalf of all of us on the call today, I'd like to welcome you to our training session. Before we get started with our technical overview, I'm going to cover just a few administrative items. Make sure that you join us each month as we provide you 2 opportunities to learn about our Resideo products. And going forward, we are going to be offering these webinars twice each month. So make sure to visit resideo.com/webinars for more information on these upcoming sessions, and navigate to either the HVAC or the plumbing tabs to find information on registering for our upcoming webinars. Additionally, you can find recorded sessions on the same website underneath the webinar recordings tab if you are unable to attend any of the live sessions. And then for our contractors who are joining us for today's live session and you are interested in earning 1 NATE continuing education credit, there are just a few things to note. If you provided your NATE ID on your registration form, we submit that information to NATE for your attendance of today's live session, and we don't need any additional information from you at this time. If you did not provide us with your NATE ID on the registration form for this webinar, and you'd like to receive credit for attending our live session, then we do ask that you email your first name, your last name, your NATE ID, and the date of the session you attended to homes.university@resideo.com within 1 week from today. This information is submitted to NATE 1 week following the close of each session. Any requests that are sent outside of 1 week from the live training cannot be processed. And as a reminder, we can only process requests for NATE credits when you attend the live webinar sessions, and we are unable to process requests for watching a recorded version of any of our sessions. For more information about the NATE program, please visit their website at www.natex.org. And then one quick note before we begin our technical presentation, all of our attendees are muted. However, if at any point during the technical presentation you'd like to ask a question, please use the Q&A feature found in your Zoom webinar controls. And we are reserving the last few minutes of our time together today to answer any questions. So as we progress through the technical overview today, and if there's anything that either Chris or Mike covered that you've got questions on, please be sure to ask your question in that Q&A feature so that we can address it at the end of today's session. Now we're going to turn over the presentation to Chris Parks, who is our water sales leader for the West Coast. And then also joining us today is Mike Ortiz, who is part of our water sales team. He's going to be helping out with today's training as well. So Chris, we're going to turn things over to you.
Thanks, Jamie, and thanks everybody for taking time out of their day today to learn about our new products. My goal today is to show you what we have coming out, or I should say actually what we just started shipping, and go through some of the technical components on it. The 4 products, for those of you that have not yet seen our product offering that we just started shipping, we have finally gotten into the variable speed circulator realm. We have begun shipping magnetic hydraulic separators. We have press air eliminators and press boiler trim kits, which round out our full press offering. So just to kind of mock up, we've had a vision for the last several years of providing a complete press offering for the mechanical room. We started launching products a few years ago, and with the addition of some new products that we have today, we can say now that we do finally round out just about everything in that mechanical room. So for those of you that do press and have invested in the press tools, we now have a complete package that we can offer to you. And what I'll be doing is going over all the new products we have in much more detail, but I wanted to give a high level overview of what we've had. We've had press mixing valves, we've had a press fill valve and backflow, and we've had press zone valves. Now with the addition of our press air eliminators and press hydroceps, we can now offer a press boiler trim kit as well. So I wanted to talk briefly about our press boiler trim kits. Boiler trim kits are something that we've offered for a while. And when you look at what goes into a mechanical room, we took 3 components that are in virtually every system and bundled them together to give you a cost competitive package. So you save a little bit of money by buying them as a package, but every system needs to have some form of air elimination, an expansion tank, as well as a fill valve and backflow. And the one exception I'll put on that is those of you that are using glycol for a glycol-based system, you won't use a fill valve and backflow. So you'll use a glycol feed system of some sort, but that's kind of the one exception. Other than glycol systems, this is pretty much the way it's done. The 3 components you have to have with virtually every boiler. So I did want to briefly talk on our NK300S fill valve and backflow. Now, this is not technically a new product, but I did want to touch on it because it does come packaged in our boiler trim kit. So we offer this today in 2 different configurations. One configuration comes with sweat and threaded tail pieces. The other configuration that you're looking at here comes with pressed tail pieces. The beauty of this is that think of this as your premium offering. We still offer a lower cost fill valve and backflow, but what this does is it offers serviceability. You can take every bit of this apart, clean it, put it back together. We ship it with a pressure gauge and isolation, so you can basically isolate it, fix it, clean it, put it back together, and get up and running. The number 1 killer for backflow preventers and fill valves on hydronic systems is sediment. So this is a big serviceability piece because you can actually get in and knock that sediment back out and put it together without having to replace it. We do also have test ports. If you look at the top couple of grayscale images that I have there, it kind of shows how you test the 2 different check assemblies inside of here. So I do want to highlight that this is a testable dual check backflow preventer, as well as it's got a combination fill valve. So one thing I do want to touch on is we've had some changes within this. So the new IPC and UPC code books, these are approved inside those books. We've had a couple jurisdictions that have fought us a little bit on this type of a product. So the code book may read today that the jurisdiction requires a testable atmospheric vent backflow assembly. Well, that is now approved in the 2021 code books. With that being said, it does take time for jurisdictions to adopt code books. I know a couple areas that are still running on the 2015 code books. So although it will be in the 2021, just something to note, it may be a couple of years before your local jurisdictions actually do end up approving it. And then getting into some of the other products. So air elimination, I'm going to talk a little bit about air elimination because it pertains to our SuperVents as well as the HydroSep that I'm talking about in much more detail here shortly. So I wanted to tackle some of the air elimination questions and some of the products that we have. There's a couple different places you can put air elimination. You commonly see it tied to the expansion tank. However, it doesn't have to be. You could technically put your air eliminator just about anywhere, although we do commonly see it on the boiler loop. When you're looking at air, there's a couple different sources. So when you first fill a system, you're filling it with an air and water mixture. So if you tie it up to the city main, or even if you're filling it from a bucket, you're actually pumping in an air and water mixture. So over time, as the system sits stagnant, what'll happen is all those little air bubbles will start to kind of clump together as the system sits stagnant, which will create much larger bubbles. The reason I'm going to talk about air elimination is it can be a major problem in hydronic heating systems. So hydronic heating systems are typically closed loop, meaning once you fill it and pressurize it, there's no more water going to be added to this mixture. So once you've isolated that system, filled, purged it, there should be no more water going back in. So what happens is as you filled it with this air and water mixture, those air bubbles are going to collect. So a couple things can take place. For those of you that do in-floor heating systems, you may have 3/8 or 1/2 inch tubing, or even in some systems, 5/16 inch, really small tubing. And if you get enough of those air bubbles in the tubes that collect, it'll actually act like an air block. And most of the residential circulators are not capable of creating enough pressure differential to push that air bubble through. So we call it an airlock. So something to keep in mind when you do your initial purge, it's a good idea to keep the circulators running after you fill and purge it, just to keep everything running through the air eliminators. The other thing I do want to touch on is there's a lot of systems that I see that have been installed for 5-6 years that end up having almost what looks like mud in the system. They're usually a culprit of something causing oxygen on a molecular level to enter the system. So one of the most common reasons for this is using the wrong type of tubing. So if the system was installed with a plumbing PEX instead of a heating PEX, and I've got a couple examples here from Uponor, but you know, Uponor makes two different tubes and they look exactly the same and the plumbing pipe is half as much. Well, the reason that hydronic PEX is much more expensive, or the heat PEX as they call it in the brand name, is because it's got an oxygen barrier on it. And you really need that in a closed loop heating system. If you don't have an oxygen barrier, you are having oxygen permeation take place inside that plastic, which is constantly introducing oxygen molecules into the system. Those oxygen molecules are going to produce rust on any kind of ferrous metal. You'll have iron oxide being created, all kinds of issues. And I've got an example here. There are third-party manufacturers that make boiler chemical inhibitors that help prevent some of this. Fernox is one of those brands. We don't have any ties to them. It's just a brand I see a lot. And this is an example they've had at some of the plumbing counters I've gone to, where they fill it 2 jugs with basically a mixture that prevents that oxygen attack. And you see common systems. You got black iron fittings in there, copper fittings. I think there's some brass. That's commonly seen in a hydronic system. And then on the right is what happens if you don't take care of that oxygen. So I'm going to talk about our air eliminators that help get rid of the air bubbles. I also want to bring up, if you do run into systems where, let's just say AquaPEX or a plumbing PEX was installed, you will need to install a stainless steel circulator. You can't use our standard pumps because they are cast iron. That cast iron will rust out essentially. So something to take note of is not only do you have to take care of the air bubbles, but if you do have the wrong type of PEX, you've got additional complications you're going to have in that system. So looking at our SuperVent, we have 2 different air elimination devices in our product portfolio. We have the old school air purger, or sometimes they're called air scoops. I'm not going to talk too much on those. What I did want to bring light to is our SuperVent that we've had for a long time. The way this works is essentially your water and air mixture passes through the coalescing media on the inside, which ours is very similar to almost looks like a stainless steel brush. And what happens is as the air bubbles pass through, they kind of stick to all the little bristles on that brush. When enough of them stick together, they're going to float up to the top. They're going to get up to the top of that air vent and push the float down when enough of them collect. So what's going to happen is that air vent's going to have the float push down. It's going to open the vent on the top, which is going to allow that air to automatically purge and come back through. So the reason we're seeing a very large, and this has been taking place over the last 10 years, we've seen a very heavy migration from air purgers or air scoops into this type of an air elimination device, is because it's much more effective at collecting the micro bubbles. So when you pass through this, if you're entering at 4 feet per second velocity, you're going through it at 4 feet per second and coming out, you need something that's going to catch those little micro bubbles. This does a very effective job. It's very, very important to use something that's effective at this type of air collection with modulating and condensing boilers, because they have much less water in them than the old cast iron boilers we used to see. So today we offer these in 3/4 inch through 2 inch, and we are expanding the product offering to offer 1 inch and 1.25 inch with press connections in the box. So they're already attached, or we warranty it from press to press on the fittings, but expanding that press offering for the solution. Now, getting into hydroseps, I've kind of briefly touched on the products that we've already had. I'm going to spend much more time talking about the technical aspects of two of the new products that we have coming out. So the first of them is hydraulic separators. This is something that's been in North America for 10 to 15 years now. We are going to be offering this, or I should say we are now offering this as a product solution in our portfolio. I used to work for a distributor where we designed systems, and I got to the point where I really enjoyed packaging these with the boilers for a number of reasons. And I'll talk to a lot of those, but the hydraulic separator accomplishes a couple of different things. So first off, it's going to be your air elimination. So when you use our product, you no longer need the SuperVent. This is going to take care of your air elimination. And I'll talk a little bit more on how that works. It's also going to do your dirt separation. So if you've got flux in the system, if you've got a little bit of Teflon tape, whatever's left in the system from the assembly, it's going to basically drop it down and collect it in the bottom of this. The other thing this is going to do is it will also do magnetic separation. That is becoming more and more important in modern hydronic systems because there's a big migration over to variable speed pumps. I started hearing rumors 10 years ago that codes are going to be changing, which are going to start requiring ECM motors. I haven't actually seen that take place, but that rumor's been around for about the last 10 years, to be honest. But there is a migration over to pumps with ECM motors, variable speed technology. And while it's a great product, it does come with some complications. One of the complications is those ECM motors are permanently magnetized, which means any kind of ferrous metals that are in the system go to the pump, stick in there, and basically they chew them up. So if you had a fixed speed PSC type motor, you might get 15, 25 years out of it. But if you had it in the same system with variable speed without any kind of way of collecting that magnetic material, you may see that thing failing in 3 to 5 years. So magnets are starting to become more and more common and requested in hydronic systems. So we are including a magnetic separation device with every single one of our hydroseps. It's a great place to put it. It's centralized between the boiler and the system, so your water is going to pass through at that point. So regardless of what side of the system that lies on, it will get trapped here in the hydrosep. Now, I wanted to talk briefly on the servicing. The way a hydrosep works, and I've got many examples of this that we're going to be kind of going through. But when your water passes through, the biggest reason that a hydrosep is affected is there is a dramatic drop in velocity as it goes in and out of the hydraulic separator. And I'm going to use that 4 feet per second example again. So on our SuperVent air eliminator, I mentioned if you're entering at 4 feet per second, going through it at 4 feet per second, it exits at 4 feet per second. It's a very different dynamic with a hydraulic separator. When the water enters, again, let's just use that 4 feet per second example, it's going to drop in velocity almost tenfold as it passes through the hydrosep. So if you're coming in at 4 feet per second, you may see 0.5 or 0.6 feet per second inside that vessel. So that's kind of how the magic of these things work, is that dramatic drop in velocity. So 2 things take place when that happens. First, the air, it gives it a chance to kind of float up. So instead of being suspended in the water, you get a chance for that air to float because of that velocity change. We do have a little stainless steel grate inside of there that's going to do an effective job of collecting. It kind of helps collect those bubbles, although it would just, those bubbles would float inside of here without that, but it does help collect them. And then 2, because that velocity is dropping as it's passing through, you get dirt, sediment, etc., that's going to fall out of suspension and collect down in the bottom of that. And then again, that magnet is there to collect any ferrous metals, just to kind of help make sure that none of that stuff does move through. From the serviceability standpoint of these, there's not a whole lot of moving parts. So it is a somewhat expensive product. However, there's not a whole lot to falter on this. Since it's basically a giant tube, there's only a couple of things you need to pay attention to from the service standpoint. First is our air vent up here at the top. This is the point where the air bubbles are going to collect. It works just like that SuperVent. So this air vent will over time fail. There are a lot of determining factors as to what the expected lifespan is. If it's a water only system, you're probably going to see 15 to 25 years out of it. If this is a glycol system, you will see that air vent fail on a much more regular basis. And those of you that have been in the industry for a long time, I'm sure you've seen that. Air vents just don't last in glycol systems. And I'm going to shed some light as to why that is. I'm not a big fan of using glycol unless you absolutely have to. There's a lot of reasons for that. I'm not going to get into too many of them on this training class, but the first is, for those of you that have been around it, and if you spill some, let's just say hypothetically, you get it on your hands, and you let it sit there in your hands for a couple of moments, what's going to happen is it's going to start getting tacky. And the reason is it starts to become a little sticky when it gets exposed to oxygen. Well, what you have inside of here is a float that swings up and down as the air bubbles collect. So essentially you have your glycol sitting here at the bottom with air coming up and a float that has to slide up and down to automatically purge it out. Well, what's happening is that tackiness starts to assemble on top of the float assembly, which then doesn't really permit that float to ride up and down as it should. So usually what I see is that float goes up a little bit, starts to come back down and sticks. So it doesn't seat all the way back. I'm actually saying that backwards. So it doesn't seat all the way up, which basically leaves this partially open. So you see this start to leaking, you see it leaking water out. So we know this is a service point. So what we've done is we have two different methods for serviceability on this. One, our residential, our union models, so that's the sizes 1 inch through 2 inch, and I'll go into the size offering in a minute. We have installed a check valve assembly right here. So the way this works is when the air vent is screwed in, it's pushing that check down so that the air and water can come up. When you start to unthread this, that check comes in, blocks the passageway of water, which allows you to remove the air vent and then take another one and screw it back in. On our bigger sizes, which I don't have an image of here, but on our flanged configurations that go from 2 inch to 6 inch, we've actually got a ball valve here. And the reason is most engineers will draw out any type of major air elimination with some form of a shutoff valve because they've been doing it for long enough to know that these air vents do fail over time. So they usually want to see a shutoff valve here. I've got an image of that later in the presentation. And then we have a blowdown down here on the bottom. So what happens is if you want to service it, clean it out, because again, you've got magnetic materials that are sticking to the magnet, you've got dirt and sediment that's fallen down here. All you have to do to service this on a regular basis is one, check your air vent, make sure it's operating. And then two, put the system in idle. Make sure there's no pumps running, give everything a second to kind of settle. Our magnet comes in two pieces. So the first is going to be a dry well that screws into a port right here. The second, the magnet screws into that dry well. This is a very, very strong magnet. Temperatures do not affect this at all. So you can run this thing at 180 degrees and not have any problem. So you unthread the magnet, pull it out. What's going to happen is all the ferrous metal that's stuck here on the well is going to drop out and fall down once you unthread that magnet. Then you're going to take a bucket. If you want to run this to a drain, great. I never really see them run to a drain, but you can. Most people will just grab a bucket or even like a large cup and just put it under here. And all you have to do is open this little drain for a second. Everything that's sitting down here in the bottom is going to kind of blow out. You're going to see that nasty brown liquid and junk kind of fall into the bucket. And then once you start seeing clear water, shut that back down. You will probably need to then go to your fill valve and put a little bit more pressure on it just to boost that static pressure up. It's not going to take much. You're only basically looking to drain this segment of water out, but you may lose a pound or two when you do that. Screw the magnet back in and turn the pump back on. That's pretty much all you have to do. Very, very simplistic from a servicing standpoint on this. And I wanted to kind of go through what the reason for using one is, some of the different operational criteria you'll run up against. The first being a system that, and an example that rarely ever takes place, but I just want to show all three different dynamics here. The first, let's say you've got a system here, and the whole point of a hydraulic separator is to create hydraulic separation between two different systems. So if you look at any modern high efficiency modulating or condensing boiler, you're going to see that they're going to want you to draw it out with some form of hydraulic separation. So they'll a lot of times draw it with closely spaced T's, and it'll put an asterisk that say a low loss header is an acceptable means as well. But what you need to do is create a difference of flow characteristic between the two systems. And the reason for that is, and I'm going to use this in the next three examples, but when a boiler specifies a pump, sometimes they'll list the flow rate they want to see. More commonly, they just tell you, use this pump on this speed. And the reason, what they're doing there is, with these newer boilers, they need to make sure, and I guess they're not really newer anymore, they've been around for a long time now, but there's not a lot of water volume in here. Even the fire tube style, there's not a ton of water sitting inside this heat exchanger. So if you don't drive enough flow through this heat exchanger on its maximum firing rate, you're essentially going to create steam inside the heat exchanger. If you create steam inside the heat exchanger over time, you're basically going to rip it apart. I've had calls on boilers where somebody tells me it sounds like there's somebody sitting down there by the boiler hitting it with a hammer. I mean, I've literally seen boilers jump when they start to cavitate to steam. So the flow is very, very critical. So what a lot of boiler manufacturers will do is they'll say, well, I've got 100,000 BTUs of output. I want to see a minimum of a 20-degree delta T. So using some math that I've explained in other training classes that we've done, you want to see 10 gallons a minute to deliver that 20-degree temperature differential across a boiler that's doing 100,000 BTUs. So I'll use this 10 gallon a minute example for a few. But what will happen is a lot of times in modern systems, you're going to see varying flow rates on the system side. So you're going to have a pump here that is dedicated to driving adequate flow through this heat exchanger on the maximum fire. And then out here on the system, as we've gone to variable speed pumps, you'll see this flow rate fluctuate dramatically. So, and I'll get into that. But in this example, if you've got a pump here driving 10 gallons a minute, it's creating a pressure differential, which is driving flow through this device. At the same time, you've got 10 gallons a minute. It's basically created a full flow situation. So you have 10 gallons a minute coming in, 10 gallons a minute going out to the system, coming back and coming back to the boiler. This rarely ever takes place in modern systems, but this can happen. This is a much more realistic example of what's going to take place. So what you have is, again, I'm going to use that 10 gallon a minute example here. So this is still the same flow rate that we've got, but now let's say we're using zone valves with a variable speed pump. So that variable speed pump is going to fluctuate the flow rate based on the number of zone valves that are open. So in this example, let's just say hypothetically, we've got one valve open. This pump is seeing the pressure there, so it's going to drive 2 gallons a minute. This pump still must maintain that 10 gallons a minute maximum flow rate to provide adequate flow. So what's going to take place is you're going to have 10 gallons a minute enter the hydrosep. You're going to have the rest of that flow come down here. So you're basically, well, here, let me explain it a different way. You're going to have 10 gallons a minute enter through the top port here. The pump on this side is going to create enough pressure differential to drive 2 gallons a minute. So you got 2 gallons a minute coming out, coming back, but it's going to marry up here. You're going to have 8 gallons a minute drop down to give you 10 gallons a minute back to the boiler. What's taking place inside of here is, since there is very little pressure drop, if any, you're creating a spot where the differentials from this circulator are not impacting the pressure differential from this circulator. The same dynamic happens in closely spaced tees if done correctly, and I'll touch on that in a minute. But this basically eliminates any air in the piping, makes it a little bit easier. It also gives you more water volume, so you don't have the displacement as much. So we see this is a very common example with variable speed pumps and valves and or actuators. Like if you're doing manifold actuators, you typically see a flow rate lower on the system side than you do on the boiler side. For those of you in markets that zone pump, you're going to get a slightly different dynamic. You've actually got the opposite thing normally taking place from my experience than if you're using a single pump with zone valves. So in this example, we're still living with this 10 gallon a minute flow around the boiler. But what's taking place is, now let's say we got a pump on every single zone. Usually in this example, from my experience, these pumps are slightly oversized unless you've got circuit setters really driving the flow to where it should. But in this example, we're driving 14 gallons a minute with all 4 pumps turned on at the same time. So in this example, we're driving more flow on the system side. So as the water comes in at 10 gallons a minute, that pump is still going to create that pressure differential, which is going to bring 10 back, but we're going to have more flow taking place over here from all the pumps. So what's happening is that differential from 14 to 10, you've got 4 gallons a minute that's going to come up through the middle and back in to come through here. And I kind of lost my train of thought on the previous slide, but what's taking place is, since there is no pressure difference here, my first manager used to tell me that, you know, water's lazy. It's going to take the path of least resistance. So since there's no pressure loss in here, and the pumps are creating more of a pressure differential, there's no reason for that water to any extra flow to push out here. It's just going to take the easiest path, which is right back to the suction of the circulators. And that's where you kind of get this flow dynamic taking place. One of the questions that I do get a lot is, well, what size hydraulic separator should I use? And some people overthink this a little bit. We do have some tables published that show our maximum flow rate capacities for each hydraulic separator. But really what's going to take place is you want to size these so you're going to have less than 4 feet per second velocity going through the hydraulic separator. When I used to design systems, we always shot for that as a maximum flow anyways, because when you start getting more than that, you'll start having noise in the system. You'll start having velocity noise issues. And then if you get much beyond that, you'll actually start having pipe erosion. So we always tried to keep the velocity below 4 feet per second, but you do have two different sides. So I'm going to keep this, here's my 10 gallon a minute example again. So let's say we've got our boiler sitting over here and it's been designed with 1 inch piping. You're kind of maxing out 1 inch at 10 GPM, but I'm just going to use that as an example. So the boiler loop is 1 inch. Out here on the system side, we'll go back to that zone pump example. Well, if we've got the capacity to drive 14 gallons a minute, we really need to be on 1.25 inch piping now. So if you look at this, what size hydraulic separator do you use? You got two ways of looking at it. One, assuming your system was designed properly, just go off the larger of whichever pipes you're connecting to. So if we have 1 inch here, 1.25 inches over here, you're going to use 1.25 inches hydraulic separator. If you want to use these different flow rates, feel free to use this as a point of reference. These are very conservative flow rates. I never designed a system for more than 14 gallons a minute on 1.25 inch pipe, but here are some recommendations on the maximum flow rate to keep this consistent. Now, I was going to touch briefly on the products that we are selling now. We started shipping these at the beginning of the month. As I had mentioned previously, we are offering the union connections in 1 inch through 2 inch sizes. When you get your tail pieces, we've designed them so that you can kind of create your own adventure as you design your system. We are selling our tail pieces in 2 packs. The reason we're doing that is some contractors like to do iron pipe off of the boiler. So we can do threaded connections here for the iron pipe hookup. And then maybe you want to do press on this side, or maybe you want to sweat on this side. So when you buy our HydroSeps, you need to make sure you buy 2 packs of fittings. And the reason is if you're doing all sweat, you can do 4 sweat connections, but you need to buy them in 2 packs of 2. As we move on to our flange sizes, this is where I was kind of telling you, we've got a slightly different connection here. It's a higher capacity air vent. We have a shutoff valve instead of that check valve. And then the blowdown valve is a little larger as well. The sizes on these, we do double up the 2 inch size. So on the 2 inch, you can use either sweat thread or press in the union connections, or you can transition over to flange. So if you're doing a commercial job that's doing Victolic or another piping method or Aquatherm, whatever you're using, you can kind of marry up to it with the flanges as appropriate. We stopped at the 6 inch size because once you go into 8 inch and larger, you have to have ASME rated vessels. So we figured we would just kind of start with the non-ASME required products. Now, one thing I do want to highlight is the hydraulic separators are dramatically more expensive than closely spaced tees. But I want to expand on that because when you break it down, they're really not. And when I was on the distributor side selling systems, I would have this conversation fairly regularly because people are used to seeing 1.25 inches. And I mean, this example, I'm using 1.25 inches, but you'd see an air separator, and I've just kind of mocked up some rough numbers here, but you'd see an air separator that's maybe $135 and a set of closely spaced tees that's maybe $20. So people will come to me and they're saying, well, why would I buy a hydraulic separator at in this example, $320 when an air eliminator and closely spaced tees are only $150? And there's a couple things I want to point out here as an analysis. So first, let's talk about the labor. Because when you look at this type of a configuration, yes, material cost is absolutely going to be less. But as I'm seeing nationally, I can speak definitively for the Western US, but when I look nationally, one of the problems that our trade has is a shortage of workers, basically. We don't have enough people in our industry to get the jobs done. So press has grown dramatically as a solution because of that. So I'm going to kind of use the same type of examples here. So in this system, very common system, you'll see it in virtually every modulating boiler manual. You're going to have an air eliminator and a set of closely spaced tees to give you a form of hydraulic separation. This way, the same examples I was showing you earlier, 10 gallons a minute or 2 gallons a minute, but you're keeping that flow consistent here. There's a couple of things you need to take into account. Look at the number of fittings you have and the number of joints that you have to make. So we've got 2 sets of T's here. So 1, 2, 3, 4, 5, 6 1.25" connections right here. Our air eliminator, we got 2 more. So now we're up to 8. I always encourage people to put Y strainers because I've seen large lumps of solder that don't, they basically fall off into the system. So I've always suggested putting a Y strainer on the boiler return as well. So now we're talking 2 more connections. So we got a total of 10 different sweat connections in this example. And if you're using press, it'd be the same thing. So I've worked with another trainer who gave me an average of 9 minutes per joint per 1.25". So if we've got any contractors in the line, I'm sure some of you will tell me you can do it faster. And I'm sure some of you will tell me we're doing it slower. 9 minutes is the average I was given by a trainer that does a lot of plumbing trades and basically helps people build out their labor costs. So if we're going to go, I'm using that as an example. And there are obviously a lot of variables here. I'm going to use a national average of about $150 an hour charged labor rate. So if we're looking at what we're coming up with, it's about $22 per joint to do that 1.25" connection. That's to cut it, clean it, prep it, mount it, solder it, etc. So if you're looking at those 10 connections, you're looking at a labor bill of roughly $225 plus the added time to get that done. If we look at the hydraulic separator, so I've got my parts here breakout. So we've got an 1.25" air sep at $135, 1.25" sweat Y strainer at $75, a couple of 1.25" T's at $25, and then our labor at $225. So our install cost out the door with labor is about $459. So let's look at this same example with an 1.25" hydraulic, 1.25" hydraulic separator. Yes, the cost is absolutely more expensive compared to what we're looking at over here. However, you only have 4 connections now. You don't need the air eliminator anymore, the SuperVent, because this is going to take care of that. So now you're looking at 4 connections, which dramatically reduces the time to install as well as the cost associated with it. So now you're looking at $400 instead of $459. So it's about a $50 savings, plus you're adding that magnetic separation, which again, as we move over to variable speed pumps, it's becoming more and more important. So this can be adapted to whatever your labor rates are, whatever your time is. What you'll find is this number is still going to come out to roughly the same cost, even if you change your labor rate and your time. This is just an example that I've used off a national average. So just something to keep in mind. Yes, the upfront cost is more, but when you factor everything, it ends up being roughly the same or less, and you're providing a lot more value to your system. And I did want to touch on our variable speed pumps. So we have finally entered the realm of variable speed pumps. We have had 3-speed fixed circulators for a while. We are now finally producing an ECM variable speed pump. So we are offering our same curve on our lower circulator, but what we're doing is we're offering it in 2 different configurations. So we got cast iron and stainless steel. And as I had mentioned previously, if you have any kind of oxygen issues on your system, you need to go to stainless steel. If you're doing hydro air that's open loop, you need to do stainless steel. So just something to keep in mind there. What we've done with our circulator is it is kind of our premium offering compared to other brands that exist. We have a digital display that's going to flash back and forth between flow rate and wattage consumption. We have 4 different variable curve settings, 3 fixed speed settings, auto adapt, and it will take a 0 to 10 volt input signal. We're also continuing our 5-year warranty, which is what we've had on our 3-speed pumps for as long as I can remember. And then just one point I wanted to bring up, when we look at overall efficiency of systems, there is roughly a 30% increase in circulator efficiency when you go to variable speed versus fixed speed. I get asked that question a lot, so I wanted to touch on that. And then I also get another question, well, how easy is it to wire up? At the end of the day, it's still kind of a tight package. I mean, if we were going to build this thing out with a giant box on it, it would look hideous, but we do have a little bit more room than some of our competition. So it's not too bad to hook up your high voltage side of this. And then if we look on the left-hand side, you'll see a couple other terminals that aren't hooked up. That is for your 0 to 10 or 4 to 20 milliamp connection. So I just wanted to give a visual indicator as far as the hookups. They are push button tabs. So we recommend using solid wire. The image here is showing stranded. I did that because you could show that stranded wire does go in here just fine. So if you're using pigtails or whatever you're using, there is some room to do your wiring. It's not overly crowded inside of there. Now getting into the different operational modes, again, I did want to reemphasize that we've got a push button there to cycle between the modes, and it will flash a visual indicator on your wattage and flow rate consumption. And I'm going to jump into what all these different curves mean. So if you look in the bottom left, that is our pump curve with every single different operation mode slapped on one setting. So I'm going to shed some light as to what these mean and where you're going to use them. So I broke out the individual curves in different settings so that I could talk about each one. And I'm going to go kind of jump around this slide, to be honest. So the first thing I want to do is highlight the auto mode. This is where I would set every single system that you operate within. What's going to happen is the pump will float inside of this curve based on the different dynamics inside the system. And we're going to keep the pump conversation a little high level, because if I went to extraneous details, this would end up being a 5-hour pump class. So I'm going to touch on what these different modes mean. If you have any additional questions, feel free to reach out to any of your Resideo reps and we can answer those for you or dive into more detail. But for today's training, I just kind of wanted to touch on what the modes were, when you use them, why you use them, etc. So my personal opinion, set this pump in auto mode every single time. It will float inside of here based on what's happening in the system. So I've created some notes on this slide, and I'm going to highlight properly designed systems. So if you have this pump and you put it in auto, and let's say it's an in-floor system, and you've designed this hydronic in-floor system for 1/2-inch tubing, and every loop being, let's just call it 225 feet. But let's say you weren't paying attention and somebody went through and laid out one loop at 350 feet. The problem is this pump in auto mode, from my experience, won't find that one extraneous loop. So when I say properly designed system, that means everything's roughly designed properly, everything's roughly the same, within the same type of criteria. If you've got one loop that's creating 3 times as much head pressure, this pump is going to have a hard time finding that one specific loop. So properly designed system, auto mode, all day, every day. If you do run into a couple other modes, or you kind of want to tweak this a little bit, we have 2 different pressure curve settings. So that's going to fall right in these different modes. So I'm going to start with PC1 and kind of work my way backwards. So PC1 is here, PC2 is right here. What you're going to do is your PC1 is a proportional pressure curve. What that means is it is going to mimic a system curve with a system like TRVs, which is an acronym for thermostatic radiator valves, or modulating valves, like modulating fan coils, etc. So what happens with this type of a system is, as your thermostatic radiator valve, it operates off a piston. So it's actually modulating the flow rate that's going into a radiator. So as a result, both your flow and your head pressure are going to fluctuate as that valve opens or closes. So TRVs or modulating valves, you can set it on a proportional pressure curve, which is going to be these first 2. If you have a zone valve system, I'm going to emphasize again, properly designed. But if you have a zone valve system, you usually have fairly consistent head pressure. So if you design a system, let's say you got 4 zones, you're going to design them with all roughly the same length of tubing, ideally. So you're going to end up with a fairly consistent head pressure requirement. What the circulator will do is it will lock in that head pressure and basically fluctuate the flow along a straight line. So zone valves or manifold loop actuators are good reasons to use a constant pressure curve. So I've got those listed in these two right here. And then we also do have the capability of running a fixed speed operation. So think of this like a basic pump. So we have been operating 3-speed circulators for a long time. The way those work is it's almost 3 pump curves in one circulator. So you buy a pump, you slap it on, you set it to the curve you need, and you walk away. That's basically what you're doing with these 3 different speeds right here. You basically have an ECM motor that's running off a fixed speed output. So it's no different than putting one of our old 3 speeds on, but getting a little bit more efficiency out of it. That's all that does. Where I've seen this used is the oopsies. The example I just gave right here, where you got one loop that's like 350 feet. Sometimes those variable speed pressure differential pumps just have a really hard time finding that one extraneous loop, and there's not a good fix unless you can cut it and bind it somewhere. So sometimes this is kind of your, oh shoot, the system, we made a mistake, it's been concreted over, let's just put it on speed 3 and call it good. So that's kind of the only reason I see to put it on a fixed speed, to be honest. But that capability is here. And I wanted to touch on our variable speed output. I'm seeing more and more boilers that are starting to provide variable speed output signals, and it makes complete sense to me. There's a couple of brands, I think IBC, Lock and Bar. I don't stay up with all the boiler brands, but they're creating variable speed outputs. I'm a big fan of using that because, as I had mentioned in the previous hydraulic separator examples, that pump, if you're using fixed speed, is designed for maintaining proper temperature differential with the boiler on maximum firing rate. Well, how often is that boiler on maximum firing rate? It should really only do that if it's calling for an indirect water heater or it's the coldest day of the year. Other than that, it should be modulating down. So what the pump or what the boiler will do is it'll send a modulating output so that it can ramp the pump up or down around the boiler loop. So if it's at 50% firing rate, instead of needing 10 gallons a minute, theoretically, it would only need 5 gallons a minute. So I'm a big advocate, go with that. It makes total sense. The way ours works is I've got a bunch of different curves here, but it will take your either a 0 to 10 or 4 to 20 milliamp signal. So if you're running this thing at, let's just say the boiler's outputting 5 volts, it will fix the speed to roughly 50% here as well. So it kind of marries the boiler firing rate to the flow going through it as well. There are third-party controllers that allow you, I mean, we even make some with our T775s that allow you to control and modulate the flow rate around the system side. I will give you a piece of opinion, and everybody knows what opinions are worth, but I'm not personally a fan of using third-party controllers to modulate variable speed pumps residentially on the system side. I've seen it. We used to make some controls and we discontinued them that did it. More times than not, they weren't programmed correctly, which led to more problems than they helped. So the pump will, as I mentioned with that auto mode, it will hunt to find the proper flow rate. So I'm a big fan of using this around the boiler loop. The capabilities are there if you want to use it on the system side. I'm not personally a fan of that myself. With that being said, I did want to bring light to some new technology that we've got. We have finally updated our water landing page. So we've been kind of jumping across a couple different websites. We have now consolidated this into our Resideo website. So this website here is updated with all of our hydronic products, plumbing products, etc. And we're continuing to put more information on there. So this is the site you want to use now for finding literature, spec sheets, submittals, diagrams, etc. So we've got all this living on this new website. And what I'm going to do now is open this up for Q&A. And what I wanted to do is also introduce one of my coworkers who's on the call. I don't think he was introduced at the beginning. We've got Mike Ortiz on the line. He is our inside sales rep for all of North America. He has a wealth of knowledge and background, and he's going to be helping me with some of these questions. So Mike, have there been any questions that have popped up?
Like we've been through most of them, Chris. You've answered them as we've kind of gone along.
All right, so one of the questions that's here is, and I apologize, I'm trying to read through this as I go here. There's a comment here, I'm just going to kind of touch on this. I'm trying to read as I go, but there's a comment about using multiple pumps and stepping up pipe sizing. And so that's correct. So that kind of links into our, where did my cursor go? That kind of links to our hydraulic separator with regards to sizing. So yeah, we do sometimes see varying pipe sizes. It's going to vary on the system, but a lot of times the boiler will have a set pipe size. So let's just say 6 gallons a minute. So if you've got 6 gallons a minute coming through the boiler, this is easily a 1-inch pipe size. There's no reason to go larger. But if you're using the outlet going to the system, different examples could come into different criteria. So let's say we got 6 pumps on there. Each one's doing 2 gallons a minute. Well, now we're up into 12 gallons a minute. So yeah, you're going to want to jump up to 1.25 inches here. If you've got some of these monster houses like I've seen, sometimes that can lead to even 2 sizes jump. So it kind of varies. It's a much more common problem with zone pump systems, or I shouldn't say problem, it's a more common dynamic with zone pumps, because usually with zone valves, you're going to be matching the boiler output on the circulator. And each of those zone valves is going to allow adequate flow. So we size that pump for maximum flow of the system, which is usually going to be less than the boiler itself.
Just got another question here about your new residential controls have no system pump connection. Why is that? And actually, our pump end switch does control the system pump on our HP ZC boards. If you're having issues with that, just let us know. Give us a call and we can walk you through how best to wire that. Also, the domestic hot water circulator pump also does run off the first zone as well and can be used in application as well.
And Mike, that was a great answer to that. And the other thing I'll bring up too, with the variable speed pumps, a lot of times you don't even have to control them. So these pumps can do, and I didn't talk on this, but they can do what's called deadheading, meaning, if you had an old 3-speed pump, you essentially had to have somewhere for that water to go. That's why we always had to give it an on-off switch, because, and I'm talking about the system side. So let's say we had 6 zone valves. You had to have at least one of them open for that pump to turn on. And that's really the predominant reason we used end switches. It's a proving switch to make sure that valve was open so that you had somewhere for that pump flow to go. Because if you didn't, that pump would basically not have anywhere for the flow to go, and it's what we would call deadheading. Over time, it would basically kill the pump. With variable speed pumps, there's pressure sensors inside of there that are actually going to identify if zones are open or not. So there's a lot of people that instead of wiring this into a control, like Mike had mentioned, our HPZCs, our hydronic panels, you can actually just put these on a pigtail and plug them into an outlet. So these can have constant power. It'll see the zone valves or manifold actuators open and close and adapt the flow as it needs. It's actually kind of cool. I'm a bit of a nerd. It's kind of neat to sit there in the mechanical room and kind of manually open valves and watch that display on the circulator flash between flow rate and wattage consumption. It's a pretty neat little thing to see. So there are a lot of people that just plug these in and essentially run them 24/7. When it's sitting idle, it's only drawing like 5 or 6 watts. So there's not hardly any electrical consumption when they're sitting idle with no flow.
Great.
And I think there's a couple more questions. Would you have to add the 2 sets of fittings to the total on your price difference quote, or is it included? Mike, that's a great question. I actually grouped them together. Now, keep in mind, those are very, very generalized prices. I'm always very careful sitting in the manufacturer's seat whenever I show a price. So I would recommend reaching out to your distributor of choice to get that. But yeah, that price comparison actually was the hydraulic separator with connections. And there is another question here. Will we be offering any composite pumps? I'm assuming you're asking if we're looking at doing domestic water recirc with that question. And the answer is stay tuned. I'll leave that very vague at this point. Today, we kind of went with the stainless steel option for some of those potable water applications. But as far as composite pumps, not today. But we are continuing to put money into research and development and come out with new products as on a pretty fairly regular basis. And if there's no more questions, what I'm going to do is I'm going to pass this back over to Jamie, and I'm going to let her talk on some of our additional training materials.
Wonderful. Thanks so much, Chris. And thanks, Mike, for walking us through all the questions and for a great training today. And thank you to all of our attendees. We do appreciate your engagement with us as we share the details of our new water products. I hope you can share in our excitement as we bring these new water products to you this month. We're going to wrap things up with just a few pieces of additional information on the trainings that we do have available. On your screen, you're going to see an image of our new online training portal. We truly do value our relationships with our contractor and our distributor partners, and training is an important piece of providing real-time information to all of you. And we recently launched an online digital training portfolio where we are publishing in-depth technical and sales trainings for all of our customers. And you can access this training by visiting the training page on our Resideo Pro website. And the first time that you access the training catalog, you'll be asked to create an account. And then going forward, you'll log into that training account to access any of those trainings that we have posted inside of your Pro Portal account. And currently we've got about 18 to 20 learning modules that are available, that are also including our T10 thermostat. We've got modules detailing our Prestige IQ thermostat as well. And we go through both the technical and service side of things. And we also talk sales trainings as well. And we encourage you to enroll and take those as you have time throughout your week. And we are adding more trainings every month to this online training catalog. And in fact, in just about another week or so, we are going to be adding 3 new dehumidification modules to our online training catalog as well. So be sure to be on the lookout for that information. And then also, if you are a Resideo Perks member, you will receive training credit when you enroll and take those online training courses as well. So we're very excited to add this online training catalog to our training offerings for all of you. And then another reminder for all of our attendees today, we are offering this customer webinar series twice each month. So make sure you join us each month for these training sessions. Go ahead and visit resideo.com/webinars, and underneath the HVAC or plumbing tabs for information to sign up for our upcoming sessions. Additionally, we are recording each of these sessions, and you can find those recordings on that same website under the webinar recordings tab as well. And then a final reminder to our contractors who did not include your NATE ID on your registration form. And if you would like to receive credit for today's session, make sure you send an email with your first name, your last name, your NATE ID to homes.university@resideo.com within 1 week from today's live session to receive credit for attending this live training. And then 2 final things to note. Once our training session ends today, you are going to be prompted to complete a survey regarding our training session. Make sure that you take a few moments to provide us with your feedback on today's training that you participated in. We are very interested in hearing your feedback, not only on today's session, and we also use that feedback to help us create future trainings, but we'd like to hear from you on topics that you'd like us to cover in the future. And then also, you're going to be receiving an email from us in just a few days that includes some follow-up information on the new water products that we reviewed today, as well as a link to the website for information on our future webinars as well. We look forward to having you join us for our next training on March 23rd, where we are going to be reviewing how you can use data to drive your IAQ sales with your customers. Thanks so much for joining us for today's Resideo webinar session. Have a great day, everyone.